Let's get started. So, good morning, everyone. My name is Scott Lowe, and I want to thank you all so much for coming in today to learn about browser extensions and Microsoft Edge. So I have a pretty jam-packed session for everyone today. There's going to be a lot of technical details, as well as actually some unannounced and unreleased features that I'm super excited to be sharing with everyone here at Ignite today. So you guys are in for a treat. So I don't want to spend too long on the introduction. I want to just jump into code as soon as possible. But I do want to start briefly by talking about the anniversary update. So that was the first major update we shipped to Windows 10 in August, and it was the first time that the public got to see extensions in Microsoft Edge. So after talking about that, I want to speak briefly to the high-level roadmap that we have going on in the upcoming release of Windows. And then I want to jump into the meat and bread of the presentation, which is going to be the journey of an extension developer. So I want us all together to step into the shoes of a Chrome developer and see just how it is to start with a simple extension in Chrome, build it up, and then port it from Chrome to Edge. And then once it's running in Edge, we'll be able to debug it, test it, package it, and deploy it. So let's get started. Again, my name is Scott. I'm a program manager on the web platform team in Seattle, Washington. And ever since I joined the team about a year and a month, I guess now, ago, I've been part of the smaller group that's working to bring extensions to Edge. So where did we land? And for those of you who aren't aware, in the anniversary update, we shipped 13 extensions to our users. So all of those are available in the Windows Store. You can see the Store Collections page. You can get to it either by searching for extensions in the store or by actually navigating in through Edge, and we'll see that in a second. In order to deliver these 13 extensions to our users, we actually went ahead and implemented 194 extension APIs. So these were a subset of Chrome's, of course, much larger set of APIs than we have. They've been in the extension game a little longer than we have, so they have a leg up. But that's this blue area here in the Venn diagram. And the way that we prioritize these APIs was to not only have the APIs necessary to light up these 13 extensions, but we also wanted to make sure that the API we delivered in the anniversary update would let us to continue to grow the extension ecosystem between our releases. So even though the public wouldn't be getting new extension APIs per se, we'd still be able to continue to onboard more and more partners and grow that ecosystem. And I'm not sure if you guys have been taking a look at what we have, but this screenshot looks a little different. We have Tamper Monkey, we have Personal Shopping Assistant, we have Turn Off the Lights. Those are a couple new extensions that we've released since the anniversary update launched, and we're continuing to work through that backlog of extensions. So again, moving into our roadmap, as I mentioned, we want to continue to grow the ecosystem. One of the ways we're doing that is by implementing new extension APIs, so that allow developers to light up new experiences for our users that aren't possible today. We want to improve our testability. So one of the things that was a pain point both internally and externally for extension developers was actually being able to test their extensions. And we've already made some improvements there that I'll be sharing with you a little bit later. Because we're implementing new extension APIs, of course, we also want to target the next set of extensions. So as I mentioned, we're already doing that, and we're going to continue pushing that forward. We want to improve the developer experience. This is a huge one. So the faster we can get developers building extensions and the fewer issues they run into, the faster we can get their extensions into the Edge ecosystem and continue to grow and scale up. And finally, last but not least, we want to improve our reliability and our performance of the platform as a whole. So since I believe I'm hoping, how many are developers here? Web developers? Awesome, awesome. So I wanted to speak in particular to improving the developer experience. This is something that was a pain point throughout the anniversary update process when we were onboarding, and I wanted to share with you what improvements we've already made in that section to make it easier for developers to join our ecosystem. So to do that, let's start off on our journey of becoming an extension developer. And before I get too far into it, I do want to step back a little bit and just provide a bit of a prologue to our story here. So for those of you who aren't familiar with extensions or who it's been a while since you've actually built an extension, let's quickly recap the architecture. So extensions come down as packages, either from the web or served from some other source. And inside of that package, it's just usually a zip file, and inside of that are just HTML, CSS, JavaScript, image files, standard web files that build the foundation of your extension. And extensions have three major contexts that you're going to want to be aware of. The first of these is the background page. So that's a script that runs all the time, regardless of what the user's seeing in their browser. And it's kind of the brain of your extension. There's content scripts. So these scripts actually are injected into the page that the user sees. And a prime example of these, if you've ever used an ad blocker before, if you notice when it collapses the divs down with the ads, that's done via a content script, just injecting CSS rules into the page to target those specific ads. And there's also UI pages. And this is kind of an umbrella term for any HTML file that's served from the extension package. So an example of these is if you've ever clicked the little icon next to the toolbar, an extension icon, and you get that drop down, that pop-up, that's an example of a UI page. And another example of these is the options page for an extension that's also served. It's just an HTML file that sits within the extension package, is served to the user. So those are the three contexts of extensions. And all three of those contexts have access to all of the extension APIs. And the two that are used to facilitate data transfer between those contexts are the runtime.sendMessage and runtime.onMessage APIs. And we'll talk more about those throughout the presentation. And last but not least, there's also a manifest file. Every extension has one. It provides metadata on the extension, such as its name, its description, what permissions it has in the browser, and it's just a JSON blob. So keeping that high-level architecture in mind, let's start in Chrome and see what a simple extension looks like there. Let's build up some functionality and then get down into porting it from Chrome to Edge. All right, can everyone see that okay in the back? Yeah, cool. So this is the manifest file of a Chrome extension. So as you can see, we have a name property here. We have a background script, that's the brain of the extension, and it's called background.js. And this persistent flag here means that it's running all the time as opposed to only when it's needed. So there's a little bit of a performance win you can do by setting this to false, but I just kept it as true for now. This extension also has a browser action. So that's the icon that you see up in the toolbar, and I'll step through that when we look at this in Chrome. It has a content script called content.js. And this matches field here defines the rules of where this content script is going to be injected. And since it says all URLs here, that means that it has permission to be injected everywhere that the extension has permission to run, which if you look down in this permission section is all HTTP and HTTPS served pages. So let's step into the scripts now and see what these are doing. So our content script, recall this is the one that gets injected everywhere, is just calling that runtime.sendMessage API. And we're passing in an object here with a message property that says hello world. So that's our message object, and it's just being broadcast to all of the extension contexts. We're also passing in a callback function, and this is a special callback function that can actually be triggered from another context that we're sending the message to signal that some processing of this message has occurred. So the only important thing to note here is what it's actually doing. So this function is just console.logging and saying that the content script received a message, and then it's printing whatever message it receives. So moving now into the background script, you can see we have an onMessage listener. And because these are just listening on the global scope, we have to run a switch statement over top of them. And in the case that we hit that hello world message from the content script, we're going to call send response. And this send response actually comes in as a parameter to the listener up here. And it's a pointer to that special function that we were passing in from the content script. So putting this all together in Chrome, if we were to load it in Chrome and take a look at the contents console, we should see a message that says content script received a message, hello from the background script. So let's move over into Chrome now. You can see I already have the extension loaded. And if I refresh the page, there's our message as we expect. And there's the browser action icon as well that shows that we have the extension enabled. So that's awesome. We've seen with just a couple lines of code just how easy it is to get an extension loaded in Chrome and how we can use the send message and on message APIs to facilitate communication. But the only thing is, like, this extension isn't that exciting. It doesn't do anything super cool. So let's spice things up a bit and add some functionality to the extension so that it counts the number of requests that the browser makes every time it tries to load a page. And we can display that count in a couple of different places. We can display it as a little badge right up here, so we can actually put the number of requests right up next to the icon here. And just for fun, let's also make it so that if you click the browser action, which currently doesn't do anything, we'll have a drop-down, one of those UI pages, and we can also display the counter there in a live updating fashion. And since it's going to be live updating, that means we'll need to use send message and on message to actually post data from the background script, which knows about the requests going out, to our pop-up. So let's jump back into code and see how that's done. So the first thing we're going to need to do is add the pop-up. So if we go to our manifest file here, and we go to the browser actions section, we add a default underscore pop-up field, and we point the path to an HTML file that we've created called popup.html. So if we take a look at what popup.html looks like, you can see it's mostly just boilerplate HTML code. We have a paragraph tag that says number of requests, and we also have a span that with an ID of num requests, which is where we'll inject the value of that variable into. And we also have a reference to popup.js, which is going to be the brains of our popup. So let's take a look at that. So again, in popup.js, we grab a reference to that num request span with document.getElementById. And we also grab a reference to the extension's background page using extension.getBackgroundPage. And the reason why we do that is because of this next method that's coming up, and it's the updateMetrics function. And in that, all we're doing is setting the innerText property equal to the value of a variable called numRequests in our background script. And we haven't actually created that variable yet, but once we finish stepping through this code, I'll uncomment some code in the background script that has it. And finally, we have another onMessage listener, which is set up the exact same way as the one in the background script, but this time we're listening for the request made message, which again is going to be sent from the background script. And every time we encounter that message, we'll call updateMetrics. So that'll tell the pop-up it's time to update and grab the latest data. So in the background script here, I'll uncomment this code. And what I'm doing here is I'm using the webRequest.onBeforeRequest event, and that is, the name implies, that's going to be fired every single time right before a request goes out of the browser. And inside of here, I'm incrementing num requests by 1. I'm calling browserAction.setBadgeText, which is going to put the count of requests right up next to the icon. And then I'm also finally sending that request made message to tell the pop-up, hey, there's an update, let's pull some new data. So let's go back into Chrome now and see what that looks like. So moving into Chrome, if I reload the extension and refresh, you can see we have a pop-up. And if I do that, you might have seen it there. If I do it fast enough, you can actually see that it's live updating as well. So that's awesome. We now have an extension that does something a little bit cooler than just displaying a message. And we saw just how easy it is to add one of these pop-up contexts and to use send message and on message to communicate between the different extension contexts. So this is where we expect most Chrome developers to be at. And they have an extension. Hopefully, maybe they'll be a little bit further ahead than this. They have something cool. But now they've heard that, hey, Microsoft Edge supports extensions, and I want to get my extension over into Microsoft Edge. And we got a lot of questions when we first announced extension support. It's like, how do I do this? And unfortunately, it was a pretty manual process for our developers early on. We renamed the Chrome.namespace to browser.namespace for cross-browser compatibility reasons. So there was a lot of, you first had to alias that out, rename all of the deprecated APIs, convert all of those over. Chrome has some deprecated APIs, so we want to rename all of those over to the ones that are supported by Edge. And it was a pretty manual process just to get something that was working in Edge. And then, of course, you had to step through and see if there were any bugs. So we got a lot of feedback on that process and saying, this is kind of painful. Is there any way we could automate this? and we listened to that feedback. So what we've actually done is we've created a tool called the Microsoft Edge Extension Toolkit. And it's available in the Windows Store. I'll include a link on my GitHub that I'll link to in this deck. So that's where you can get all of these tools from. And what it does is a couple things. First of all, it's going to take a look at all of the APIs you use, and it's going to polyfill those out. So it's going to look at your background script and your content script and make sure that all the calls to Chrome APIs are converted to their appropriate Edge counterparts. And it's going to do that automatically for you, so you don't have to worry. And the other thing it's going to do is run static analysis over your manifest file. And it's going to make sure that any nuances, there's some nuances between our manifest format and Chrome's manifest format. It's going to make sure that you have a valid Edge manifest so that you can go ahead and load your extension in Edge. So let's take a look now at the Microsoft Edge Extension Toolkit and see just how easy it is to convert an extension from Chrome to Edge. So this is the toolkit. The first time you open it, you'll just see a blank page here that says, a button that says Load Extension to Convert. And we're going to go ahead and click that button and select the extension. This is the exact same folder that was sideloaded in Chrome. We're going to go ahead, and as you can see, it runs the conversion in place. So we have the background script and the content script API bridge. Those are those polyfills that I was talking about. And if we scroll down here, it also displays any errors, warnings, or other information that it encountered as it tried to do the conversion process. And in this case, it looks like we have an error. It says that the author string is too short. So if we scroll up, so the reason why it's doing this is because in Chrome, the author field is optional. And in Edge, we decided to make it mandatory. So what the tool did is it scanned our manifest file. It said, oh, there is no author field. So it went ahead and inserted one, but it didn't know what to set the value to. So it just left it blank and popped us a message that said, hey, make sure you fill this in before you try to load your extension in Edge. So we'll go ahead here and add Microsoft as our author. And if I save, let's see, you'll get an option here that says your extension is ready for testing, and click here to see next steps. And if you click that, you'll get taken to a page that'll walk through exactly the steps that I'm going to show you now. So in Edge, if you are a brand new extension developer, the first thing you're going to have to do is enable the extension developer features. And to do that, you go to About Flags. This is our advanced settings pane. And if you look under developer settings, there's an option for enable extension developer features. So we're going to go ahead and check that box and then restart the browser so that those changes take effect. And now we should be ready to actually sideload this extension in Edge. And for those of you who aren't familiar with the term sideloading, it's simply taking the loose extension files that are on your disk and loading them into Edge just like they were packaged. So it's skipping that entire packaging step. So to load an extension, you go up to the More menu here. You go down to Extensions. And you can see we now have an option that says Load Extensions, in addition to the extension, or the option to get extensions from the store. And this wouldn't appear if we hadn't gone in and checked that About Flags option. So let's hit Load Extension. We'll grab our demo. This is the converted version now. And you can see it appears in our extensions pane as we expect. Now, one thing that's happening here that you might not expect if you're coming from Chrome is the fact that, remember that browser action? Where is it? It's not showing up anywhere. And we did this by design. We wanted to make sure that any users of extensions didn't have a whole bunch of browser action icons along the top here. And we wanted to make sure that our users stayed in control of what they did and didn't see. So to get that browser action showing up as it does in Chrome, you can simply go to the More menu. Here's all of our extensions. So if you had multiple, you just see the icons lined up here. You can right-click on it, and you can go Show Next to Address Bar. So now it's showing up there just as it is in Chrome. And if we navigate to Bing.com, and you can see our counter's already going, that's a good sign. It means something's working. And if we go to the console and refresh, you can see we have our message there, and we have the pop-up live updating as we expect. So I can refresh it one more time here. That's awesome. So we have an extension now that works in Edge. Except, oh, this is weird. It looks like we're getting some sort of error in our content script that we weren't seeing in Chrome before. And it only happened, we refreshed the page a couple times, but it looked like it only happened after we opened our pop-up. So that's really bizarre. So let's use the F12 tools now to debug this extension and figure out what's going on, because something's definitely not right. So the first thing you'll notice in the console is it says content.js. And that means that the error's coming from our content script. So if we click that, we'll be taken right to the content script. And you can see this black arrow here will point to exactly which line of code is failing. So if I go and click in this gray area here to set a breakpoint and refresh, you can see we're now paused on that line. And, it looks like our response is undefined. Now, if you recall, this special function was the one that was called the send response in the background script. So it looks like for whatever reason, that response object isn't being created properly. So something's probably going wrong in the background script. So let's debug our background script to figure out what's going on. And to do that, we just go up to the More menu. We go down to Extensions. We click the extension we want to debug. And if we have that About Flags option checked, there's a couple developer features here. And one of these is Inspect Background Page. So if we click that, it will open another version of F12 tools over top. And the only difference between this one and the one we just saw is the fact that this is connected to the background context of your extension instead of the page. So in our file picker here, we can crack this open and get to our background script. And let's set a breakpoint here on line 4, because that looks like that's the send response call that we think is failing. So if we jump back into Edge and refresh, you can see we now have a breakpoint in our background script. And it's really weird. I was thinking maybe like send response was undefined, but it looks like this should be working. Like it's just a simple JavaScript object creation. Who knows what's going on? So let's hit continue here, and it doesn't look like there's any errors in our console. So it looks like our background script is working. Let's go back to the content, but we're still getting that message. So now that we've debugged through the content and the background flow, it looks like we've uncovered a bug in Edge. And that's possible when you're debugging your code, that you'll come across something that should be working just fine, but isn't working in Edge and works in Chrome for whatever reason. This happened fairly often with our extension partners as we were first rolling out our insider builds. And the process for getting these resolved was pretty painful. Developers would have to reach out to us via email. They'd send us a full-blown version of their extension and say, hey, when I do this workflow, it's broken. And we'd have to go reduce the issue, see what was going on, see if there was a workaround, and if there wasn't, then developers would have to fix whatever the bug was, and we'd have to wait for an insider preview build to pop with the fix in it that we could then give back to our partners. So the turnaround time on these was pretty long, and because it was via email, it was very slow, and other developers that ran into similar issues wouldn't be able to get that feedback. So we thought about this, and we said, okay, we can probably do better. And what I'm excited to announce today is that all of the extension issues that we have, both internally and externally filed, are available on the Microsoft Edge HTML issue tracker. So how many people have actually used the issue tracker before? Ooh, no one. Okay. So if you go to aka.ms/edgeissues, this is our issue tracker for Edge. It's a public bug database of all of the issues that we have exposed publicly for Edge HTML. And there's a button here, as you can see, to open a new issue. So that means that if you think you found a bug in Edge HTML, be it extensions or something else, you can go ahead and click that and file a bug, and it will get routed to the appropriate person. And of course, as part of this new announcement, one of the categories in this open new issue wizard is extensions. So you can go ahead and open an extension issue. So if we scroll down a little bit, you can see these are all of the bug reports that we have. And we can go ahead and search for issues here. And it looks like we can search for send response, because that's something that was related to the issue we were seeing. So it's actually auto-completing. Looks like I practiced my presentation a few times. And if we go ahead and run this search here, let's see, is this going to work? Maybe. Let me refresh this here. Send response, there we go. You can see we have a single issue being hit, and it says that if you add an on-message listener in a pop-up, it actually breaks communication between your content and your background scripts. Sounds exactly like the problem we were seeing with our extension. So let's go ahead and drill into this. So as I drill into this, you can see the status is confirmed. That means that someone internal to Microsoft has actually looked at this bug and said, yeah, this is a legitimate issue, and there's someone assigned to fix it in a future release. And if we keep scrolling down here, another thing that's pretty cool is if you're signed in with your MSA, you'll actually get a button here that says Me Too. So you can go ahead and click that button and upvote this bug within our own internal database. And the awesome thing about that is that it'll get a pair of eyes on it even sooner. That being said, the issue tracker is great because there's not a complicated triage process for these bugs. For instance, if you go ahead and create an extension bug, it's getting assigned directly to me. So I'm going to go ahead and take a look at it and make sure that we at least have a pair of eyes on it. You might not see that there might be a delay in actually getting a reply on the bug because we might be investigating it on our end, but there is a set of eyes within a couple days on this, which we think is awesome. It really builds a sense of community within the web dev environment. So if we keep scrolling down here, we have the steps to reproduce, and we love developers that actually give us reduced versions of the code that we can immediately try. So I was actually the one that took a look at this bug, and it was great. I could just copy paste everything over, said, hey, yep, there's an issue. And at the very bottom here, we actually have the ability to comment on these bugs from our internal Visual Studio instance. So someone named Scott L., who knows who that is, has commented on this bug, and they're from the Microsoft Edge team, and saying, yep, this is a bug, and I actually was able to find a workaround for this bug. So I provided this to the partner, and they actually reached out over email and said, this is awesome, like this unblocked us from porting our extension, so this is great. And any developer who runs into this issue in the future, because it's public, can go ahead and search this bug database, find this workaround, and say, oh, cool, there's actually something I can do, rather than just being stuck until a new build comes out. So we're really excited about that. And for those of you who are curious, I have quickly implemented the workaround. So to give you a little bit of background on this bug, we haven't fully dug into it internally yet, but it is exactly as the title said. If you have a message listener and a pop-up, for whatever reason, send response, but only send response doesn't work anymore. So the easy work around it is to use the tabs.sendMessage API instead. So what that's going to do is from the background script, it's going to target a specific tab to send a message back to. And since we're referencing the sender.tab.id property, that's a special property that lets us basically reply back to the same tab that sent the background script this message originally, which is the exact same thing that sendResponse would be doing under the hood. So instead of calling sendResponse, we're going to call tabs.sendMessage. We're going to send that message back down to that tab that says hello from the background script. And in the content script, rather than passing in that send message function in the send message call, we're going to have an on message listener that is going to listen for that message that's coming back now from the background script and run the exact same functionality, that console.log. So if we want to see what this looks like, we can go back into Edge. We can click on the More menu, click on Extensions, and we can right-click and remove the broken extension that we have. And we can load up the fixed version of the extension here. And I will quickly promote that to the address bar so we can see what's going on. And if I go to bing.com, open our console here, and open the pop-up, which should have broken the old one. We can see now, if we refresh, we still have a live updating pop-up. We still have the message being displayed, and we can refresh multiple times, and we've actually worked around that issue. So that is porting an extension. We saw how to take a Chrome extension and use the Microsoft Edge extension toolkit to get it working in Chrome very, very, very fast. And we've also seen what to do if there's a bug in your code, which there could be, and how to debug both the content script and the background script of an extension to identify what's going on. And finally, we saw if seems to be an issue in Edge itself, we can actually go and use the Edge HTML issue tracker to either search for that bug, and if it doesn't exist, file a new one. So now that you have your extension working in Microsoft Edge, the next thing you're probably going to want to do is write some tests for it. And previously, the only thing that we had available to extension developers was unit testing. There wasn't really a way to end-to-end test your extension. And something that we actually did and didn't document in the anniversary update was we actually shipped the ability to sideload an extension in Microsoft WebDriver for Edge. So how many of you have used WebDriver before to write end-to-end tests? Okay, cool. So for those of you who aren't familiar with WebDriver, it's essentially a W3C specification that outlines a set of commands that can be sent to a browser. And based on those commands, the browser will do something automatically. So for instance, you could send a command to click an element on the page. You could send an element to open a new window, do a navigate, all sorts of things. And one of the most popular implementations of the WebDriver specification is the open source framework called Selenium. And when you're writing a test in Selenium, it's basically broken into two halves. You have the Selenium language bindings. These are just files that you drop into your project that let you write WebDriver code in a language of your choice. So it could be Java, JavaScript, Python, C#, just to name a few. And once you've written your test harness in that language, you then go and download the server component of WebDriver. And these are made by browser vendors. So Chrome actually has one called Chrome Driver, and Edge, of course, has one called Microsoft WebDriver. And you drop those onto your machine, on your path, and when you spin up your test harness that you've written, it will actually go ahead and spin up that server component as well. And what that server component does is it just opens an HTTP port and listens on that port, and all of the commands get sent across via JSON, just JSON blobs that go across the wire. So you can man-in-the-middle attack them and take a look at them if you want. It's not that exciting. But once the server receives those JSON blobs, it will crack them open, see what's in them, and then drive the browser and run the appropriate command. So keeping all of that in mind, I've actually written a very small C# demo that shows just how easy it is to sideload your extension in Microsoft Edge WebDriver. So this is the first crucial step to actually testing your extension. You need to get it loaded in Edge when it spins up in the special WebDriver mode, and then you can send commands to the browser with the extension enabled. So it's very short, so we'll just step through it very quickly line by line. So the first thing I have to do is define this special sideload path. And this is a subtle nuance between our implementation of this and Chrome, who actually supports this as well. We have to make sure that all of the extensions that get sideloaded are copied to a special folder that Edge has permission to read from. So this is your local application data folder /packages /Microsoft Edge /local state. And this last folder here called extensions doesn't matter. It can be named whatever you want. But I just call it extensions so that I'm keeping the local state folder clean. Luckily, it's relatively easy to get code from one place to another on the machine. So yeah. This GUID here? No, that's actually the certificate GUID for the Windows Store. So anything that comes from the Windows Store is signed with that GUID. Cool. Or from the Microsoft account. All right, so I've written a quick copy extension for sideload method that takes in a path, runs xcopy, and copies things from one folder to that special sideloaded path. And I also have a remove sideload directory folder that I'm going to be calling in between tests to make sure that I'm starting afresh every single time. So it'll blow away that extension, recopy it, and making sure that everything is brand new. And then we're already down to our main method. So the first thing I do is I create an Edge options object. And this object is just a dictionary. It's a collection of key value pairs. And it's passed into the constructor of our WebDriver instance, which spins up a new window. So based on what's there, we can configure the session that starts in different ways. So I then call remove sideload directory. I copy the fixed version of the extension over to the special sideloaded path. And then all I have to do is create the extension paths capabilities object, which I'll add to the Edge options object. So to do that, I just create a string array with the absolute path to the extension that I copied. You could add a number of absolute paths here if you had a number of extensions to sideload. In this case, we're doing just one, so there's only one value here. And then I call add additional capability. And the important part here is the fact that the key has to be named exactly like this. Extension paths, camel cased, and the value is going to be the string array that I created in the previous step. And then we're ready to start doing our tests. So I can spin up a new instance of Edge Driver, which will pop a new window. And in this case, the test isn't doing, well, anything. It's just maximizing the window, navigating to Bing to show what's possible. So let's go ahead and run this. can see it'll spin up our HTTP server, navigates to Bing, and the extension is up there in the corner already loaded. So we know this isn't the full end-to-end experience. So for example, there's no way currently to click on this browser action. There's no way to switch to the extension pop-up context here to like do a query selector on this element here to get its value to know if the extension is working properly. But currently that doesn't exist in any browser. And I am excited to say that we are going to be investing in this. We think WebDriver is the right way to test your extension. And in an upcoming release of Windows, we will actually have the ability to interact with browser Chrome. So to click and open up both browser actions and page actions, and also switch to that pop-up context. So you can actually start writing full end-to-end scenarios of your extensions in Edge. So one thing that you can do immediately, though, is if you had something like an ad blocker, if you were an ad blocker company, or if you had another extension that modified the page with content scripts, you could actually load the extension up, and because a WebDriver executes in the context of the page, you could verify if various things were happening on the page. So for example, if you had an ad blocking test page, you could say, hey, are these divs actually not showing up? Did the correct CSS rules apply? That sort of thing. So this is the crucial first step to getting your extensions tested fully EDE, and we're really excited to be on par with Chrome and investing heavily in WebDriver to make testing extensions even better moving forward. So now I want to move to the final part of our journey, and this is something that we get the most number of questions about every single time. It's, well, how do I package my extension, and how do I get it to users? And before I jump too far into packaging, I just want to pull back and talk about what that experience is like in Chrome. So in Chrome, all of the extensions come down as what are called CRX files. They're essentially zip files with a little bit of extra metadata. And the process for creating those CRX files is pretty slick. You drag and drop your extension zip file into the Chrome developer portal. It converts it to CRX. It uploads it automatically. It's pretty polished. And Microsoft Edge, because all of our extensions come through from the Windows Store, we needed to piggyback on as much of the existing store infrastructure as possible. So that means that Edge extensions actually come down as AppX files, just the same as modern Windows applications. So the only downside to that was the process for generating an AppX wasn't very friendly to our extension developers who are used to Chrome's very simple method. When we first started this process, we actually had a 34-page PDF that we would email to our extension devs and say, hey, here you go, here's how you first start creating an AppX. And it was pretty bad. You had to scaffold your AppX properly, so you had to create a certain folder structure. There's an AppX has what's called an AppX manifest file. It's an XML file that contains all the metadata to tell the store and the system about what the extension or app does. So we had a boilerplate XML file that they'd have to copy over into a text editor and copy a bunch of values manually. And once that scaffolding process was done, once that AppX manifest was created, then they had to actually package the AppX. And this is something that required a Windows machine because we had to use the Make AppX tool, which is only available on Windows. So a lot of our developers were just like, hold up, like full stop. We don't use Windows to dev. So we'll test on Windows, sure, when we're building our Edge extension. But if we just want to do something quick, like a string change or an image change, for example, we don't want to have to spin up a Windows VM, make sure that the SDK is installed, and do everything just to build that AppX and then get it submitted to the store. So we got a lot of feedback. I think almost every partner we worked with was just like, we'll do it, but it's, please improve this as soon as you can. So the final thing that I'm really happy to announce today is the fact that we have partnered with Manifold.js, which is a tool that is open source, built on top of Node, and it lets you package all different types of things. We've actually added the capability to build an Edge extension AppX into Manifold.js. So let's just take a look at a quick demo and see just how easy it is. It went from 34 pages to, well, I'll show you. So these are the two commands that you need to build an extension AppX using Manifold. So I'm just going to copy each of these here. And I'm going to jump into a empty folder. This is just where the package is going to be output to. And I'm going to run this first command. So this is the scaffolding command. So it's going to, you can see up at the top here, it actually cracked our extension manifest open, that JSON file, and it did basically all of the steps that we used to make our developers do by hand. So it took a look at the extension manifest, it copied the appropriate values over, it created the appropriate folder structure, it made sure that everything was good to go, and we can take a look and see exactly what that command did. So going into our previously empty folder, we go a couple folders deep here. This is the guts of our AppX. Once we package it, this will be what's inside of it. So the first thing it did was create an assets folder. And if you were a brand new extension developer, the first thing you'd want to do is come into this folder and replace all these placeholder images with the appropriately sized versions of your extension logo. And these are going to be displayed in various spots throughout the UI. I believe the 150 and 151 is displayed on the store product page. And the smaller one, the 44 by 44, actually shows up in the add remove programs pane. Because again, extensions are just apps. So you can also manage them in add remove programs as in addition to managing them in Edge as well. So the next folder we have here is the extension folder. And this should look pretty familiar to anyone. This is just a copy of all of our extension files directly over into this folder here. So the API bridges are there. Everything else is there as well. Nothing changed. And then we have this AppX manifest file. And let's crack this open. With code. And see what is inside of it. So the first thing you'll notice is this identity node. And this is still one of the manual parts that you'll have to do as an extension developer. There's a name, a publisher, and a publisher display name property that you'll have to add in here manually. And these come from the Windows Dev Center. So when you sign up for a developer account, you'll sign up with your name, and the publisher ID and the publisher display name will be generated. So you'll just have to go sign into your Dev Center account and copy and paste the values here. But luckily, we can just say Microsoft for all of these and fill them in really quickly. We are looking for ways to automate this process as well so that you won't even have to do this step, but currently this is how the workflow is. And if we keep scrolling down, another thing you'll see is this resources section of the manifest. And this is pretty cool because if your extension's localized, so if you have the locales folder, the same thing that Chrome supports for all the different locales of your extension, it'll actually read all of the languages that your extension supports from the folder, and it'll create the appropriate language resource tags here. So previously this was all manual. If you supported 50 languages, you created 50 tags, and the language tags weren't always the exact same as the one that Chrome used, so we had a big table that you would have to reference to get these included as well. But now that's all taken care of for you. And then we're down into the application section. So you can see we have some metadata, the name and the description that actually got copied straight over from the extension manifest. And we also have some metadata here that tells Windows and tells the store that this is a special type of AppX. So AppXs usually have binary information. They're binary applications. And in this case, since extensions are just web-based technologies, they only have, well, they don't have binary. So we had to add some special metadata here so that the store didn't be like, where's your binary code? So this is identifying that we're an extension of Microsoft Edge. And then finally, we have a capabilities section here. Now, capabilities are something that the store product display page reports to users. And how this was populated is we actually scanned the extension manifest and looked in that permission section, if you remember, and we copied over the correct capabilities that map over to the store. So that means that now, if anyone's looking at your extension in the store, they'll see, hey, this thing is able to access your browsing traffic, for example, because we're using that web request API. So now that we've gone ahead and filled in all of the values for our extension, we can jump back to our commands And again, it's just one other command that we have to run to actually do the packaging process, which is actually going to generate that Apex for us. So let's go ahead and run that. And that's going to go along. And one thing that I want to draw your attention to, you might not be able to see actually, is this line of code right here. It says, or this debug statement, sorry. It says, unable to create the package locally, invoking Cloud Apex service. So this means that this tool tried to look on my path for that make Apex tool, and it couldn't find it because I don't have the SDK installed. And rather than just stopping and saying, well, I can't build an Apex, it actually decided to use Cloud Apex, which is a service that you can upload files to the cloud. It'll automatically generate an Apex package and then re-download that built Apex to your machine. So we think this is huge because it means now, finally, any developer could install this tool on Mac, on Unix, and they don't have to be on a Windows machine to actually build their extension Apex anymore. It'll upload it to the cloud, and the Apex will actually come down automatically. So let's take a look at that finalized process. If we go into our package folder, that is our Apex, and it was generated by the cloud. So unfortunately, I can't actually install this in Edge. It's not signed properly because it just came down from the web, but there is a full set of instructions on how to sign this Apex on my GitHub account. So you can take a look at that and see just how to sign it so that that way you can test to make sure that it's being installed and works properly in Edge before you submit it to the Windows Store or push it out to your enterprise users. So to recap, we saw how to package an extension. We saw just how easy it is to use Manifold.js to build an extension Apex, and we saw how painful it used to be with all of those manifest creation that had to be done manually. So that's the end of our journey. We've come full circle. We've seen how to build an extension in Chrome. We've seen how to convert it to Edge, and we've seen how to test, debug, and package it as well. So before we wrap up, I do just want to provide a quick note in terms of deployment, because this is what we get a lot of questions on. Everyone always says, well, how do I get it into the Windows Store? And right now, the Windows Store is a managed experience. So that means that Microsoft, like a team of our engineers, are looking at every single extension that we have before it goes live into the store. And the reason why we're doing that is because we want to make sure that all of the extensions are high quality. So we want to make sure as well that any performance bugs, so any increases of page load time or memory consumption that might be edge bugs, aren't impacting our users. So we want to make sure, because the platform is so new and it's still in its infancy, that we are going slow and making sure that all of our extensions are performant. If you're interested in deploying internally, though, so if you're an extension developer in the enterprise and you just want to deploy an extension to your enterprise users, then it's really easy to deploy an extension Apex. You can just do the exact same thing that you're using to deploy an Apex to your customers already, so a native Windows app, for example. And as long as you can get the extension Apex installed on the machine, if it's signed properly and all of that, then Edge will automatically pick it up and install it when you start Edge. So yeah, that is the end of our presentation. I think I have a few minutes for questions, so if there's any, I'd be glad to take them. Feel free to reach out to MS Edge Dev or myself on Twitter if there's anything you forgot to ask today. And there's also a link to my GitHub there in the slides, so you can see the documentation, the slide deck's there, and all of the code is there as well. So yeah, thanks so much. This is my first Ignite, so I'm really happy that I had the opportunity to come here and speak to everyone today. And hopefully I'll see you again soon. Thanks. Questions? Yeah. Native messaging? It's something we are considering right now, yes. Yes, we've heard quite a few extension developers say we need the ability to talk to native components, so it is on our roadmap and something we're looking into. Awesome, thank you.